My name is Ian Watson, and I am the Executive Director of the American Membrane Technology Association. About 2 years ago, or 2.5 years ago, the association decided that it would be interesting and also a benefit to our industry to record some conversations with some of the people that have been pioneers and have developed membrane technology or have assisted in developing membrane technology to where it is today. This is the fourth in the series. We started in San Diego 2 years ago, continued with 2 interviews in Miami Beach last year, and I'm very pleased that we have here today 2 people that I've known for a long time, Mr. Jim Lozier and Mr. Bob Bergman, both of whom now work for the consulting firm of CH2M Hill, but have had a long and varied career in the application of membrane technology. With that, I'd like to ask Jim to tell us a few words about yourself.
Thank you, Ian. Well, I've been working in the membrane industry for 30 years, a little over 30 years. I graduated from the University of Arizona in 1983 with a master's degree, and then from there I went to work my first job in the profession at the Yuma Desalting Test Facility in Yuma, Arizona, and I worked there for about a year and 5 or 6 months. And at that point I moved to a position with Engineering Science, who was absorbed eventually by Parsons, and took a job working as a field engineer on a project with the U.S. Navy up in Port Hueneme, California. And after working for a year for Engineering Science, decided I liked living in that part of the country, coming from Yuma, not a hard thing to understand. And so I went to work for the Navy directly and stayed there for about 5 years until 1989, when I had a call from a colleague who I'd worked with at Yuma, Mr. Dean Bedford, who was with CH2M Hill, and asked me if I would like to come to work with him and Mr. Bergman. So at that point I made a transition from the government position with the Navy to a job with a consulting firm and moved to Gainesville, Florida, and have been with CH2M Hill since then.
And when I was looking at your resume, Bob, I noticed that you also had worked at Yuma, and I didn't know that. So that came as somewhat of a surprise. But you were there shortly before Jim arrived, and you also worked for Planning Research Corporation at the time?
Yes, I did. I started out, I graduated from the University of Illinois in 1972, and I worked for a consulting firm there, and then I went on to work for a water utility, investor-owned water utility called Northern Illinois Water Corporation. And I was there about 6 years total in Illinois after graduating. Then I moved to Yuma, Arizona. And I was at Yuma for about 3 years, working for Planning Research Corporation. And then I ended up moving up to San Jose, California, working for Polymetrics. And after Polymetrics, I went to CH2M Hill, and I've been at CH in Gainesville, Florida now for 28 years.
Yeah, it's been a long time. I moved to Florida in 1977, so
1984 for me.
that's a long time ago.
I like
you must have had a shock moving from Illinois to Yuma.
Yes,
Geographically,
but it was nice. I was working at this water utility, and we had a lot of. It was just past a winter time when we had a lot of frozen water meters, a lot of water main breaks, and I'd have to go out and check it out, no matter when it was, middle of the night or whatever, get up out of bed, go and check it out. And if it was something that was bad enough, I'd have to call out a crew to go out. And it was just a terrible winter. And then I got this call about maybe interviewing in Arizona. And I looked at my map, and I saw mountains and desert and warm weather, and I said, I'm going to go down there and try it out. That's how I got started in desalting.
what were you doing down there?
At Yuma?
At Yuma.
I started out as senior pretreatment engineer and at the Yuma Desalting Test Facility, and was in charge of all the pretreatment test programs in front of the desalting equipment. And Jim Slay was the senior desalting engineer, the senior engineer. And after a couple of years down there, Jim left. We were ending our 3-year contract that the PRC had with the Bureau of Reclamation. And then I took over as a senior engineer position, and so that's what I was doing.
That was work that was done in preparation for the construction of the big
Correct. We were
Yuma desalting facility?
We were developing design criteria and doing various test programs that the Bureau in Denver wanted to find out some of the results. We're looking at design criteria for the 72 MGD Yuma desalting plant.
Right. And then you followed up doing the same kind of work there?
Yes, when I came in 81, we kicked off the fouling component study, which was put together to look at what was causing the fouling on the reverse osmosis membranes. The rate of flux decline was greater than what had been anticipated, and so we put a program together and looked at various pretreatments. And one of the interesting outcomes of that program was that we actually identified that if you took the water that was treated by lime softening filtration, put it through GAC and UF, and this time it was spiral on UF, we could actually get a negative SDI out of that water. And because we had a negative SDI, we had
That's interesting.
The Bureau had developed the automatic SDI monitor using a tape, which gave you a lot of ability to get a lot of results. So you had a very statistically robust database. So when we looked at all the data, and we figured out, well, what's going on here, but we determined that what was happening was the Triton X100 surfactant they put into the pad to wet it provided a little bit of resistance, and when it was washed out after 15 minutes and you don't have any foulants present, you got a negative SDI. That was published in
It's interesting.
Desalination Journal, I think, back in 84, 85.
Yeah. Now, this was the pilot testing you were doing there on the reverse osmosis itself. Did that was that a full scale? Did you actually test the 12-inch fluid systems modules?
Yeah, there were what they call proof test units there, which utilized 12-inch and 8.5-inch elements. Bob can comment more.
Well, when I was there, they were testing all different kinds of elements, the envirogenics, one with all the membranes.
The Gatling gun.
The Gatling gun style.
Yeah,
and everything else. Ionics had electrodialysis out there, and we were, Dow had their hollow fiber low pressure, and DuPont was there, and hydronautics and fluid systems.
Yeah,
and
new kid on the block, hydronautics.
Yeah, it was pretty interesting. A lot of different things going on.
So did either one of you get involved in the controversial selection of fluid systems and hydronautics and the resulting multi-year lawsuit?
I didn't get involved in it. I know something about it. From what I understand, that at that time, I don't know if it was written or just understood that there was a couple things going on, that the Bureau was going to want to select one technology, and I'm sorry, more than one technology. And so Ionics electrodialysis thought that they had a good shot being a separate technology. And I think also it surprised people, if I remember right, that Fluid Systems bid a larger capacity than some of the other companies thought they could. They thought it was going to be in increments, and of course, I think Hydronautics was 22 MGD or something like that.
Well, they ended up putting in a third of the capacity of the
third
plant.
of the capacity, in Fluid Systems, most of it.
And that was Hydronautics' 8.5-inch element, as I recall.
Yes, and Fluid Systems, they were all cellulose acetate membranes, and 12 and 3/4 inch for Fluid Systems.
After because the lawsuit went on for a long time, as I recall, several years. And after it was finished, some of us were surprised that the Bureau didn't go out, because a lot of development had taken place in the membrane technology area in the intervening years. And there were much better membranes available on the market at that point than the ones that you had actually tested at Yuma. And somebody told me that Bureau could not do that, because if they did that, they would have to restart the whole process and let everybody have a shot at it again.
Well, it's interesting. I'm still working with the Bureau on Yuma. and looking at pretreatment improvements and membrane changes. And some of the same people that were there when I worked there 30 years ago, Chuck Moody, for instance, is still there.
Still
so it's
there.
interesting to kind of do a full circle here with Yuma. But yeah, I mean, the mentality that I see is that you'd have to start the process over. The Bureau isn't going to kind of jump into a selection the way utility would do or private industry would do. So yeah, I think that would be the issue. What's interesting is when I came there, looking at the performance of the hydronautics versus the fluid systems, and the hydronautics was based upon Bray's formula for manufacturing the CA, is that there was a difference in the CA performance. The compaction on the fluid systems was greater than on the hydronautics because of the way Bray had formulated the interface between the skin and the supporting layer. So there's some differences in the performance, and people felt like Bray's product was actually better from that perspective.
Right. Right.
Also, if you look at it, the human desalting test facility was in operation for over 10 years at that time. And if they went to another membrane and they were so concerned about fouling, they would say, well, a lot of data was not useful anymore.
Useful, right, yeah. So after Yuma, Bob, you went to Polymetrics.
Yes.
And Polymetrics was one of the pioneering original equipment manufacturers in the business. I remember when I first went down to Florida in '77, they had just built the Venice plant, which unfortunately is no longer there, but at least the Polymetrics part of it is no longer there. What else did you do at Polymetrics?
Well, at Polymetrics, when I joined Polymetrics, they had just won the Yanbu, Saudi Arabia project, and it was seawater RO. They were building the Yanbu industrial city on the Red Sea side of the western side of Saudi Arabia, and they had a temporary distillation plant to provide water for the industrial city as it was being built, and they needed more water quickly. So they had this contract that Polymetrics ended up buying. I think it was a 1.3 MGD seawater desalting plant. Again, a temporary plant. It was going to run for a number of years before they brought in a barge-mounted distillation plant, and then later on a permanent plant. And so it was interesting. That gave me the opportunity because Polymetrics more than doubled their annual sales by just that one project, and they needed to hire a lot of people. So I came in there and worked on that project, and it included a 2-year O&M contract behind it. So it was design, build, and operate. And it went very successful. A couple of interesting things about that plant is that the contract itself, from contract signing to producing the water, had to be done in 6 months. And there were huge penalties at that time for us if we didn't meet that deadline. And we had to start from scratch. They gave us an area. We had to drill wells, find out the water quality, design the plant, get all the equipment over there, build it, and get it operated in 6 months. And if you think about 6 months, I mean, some of the equipment, if you say, well, it takes 6 months delivery on equipment, right? But it was interesting. We were able to do it. And I remember the night before the deadline, I was out with other people. We were connecting the main big fiberglass pipe outside that would connect it to the finished water tank. And a dust storm came by, and we're sitting there with our all wrapped up and like Lawrence of Arabia trying to complete this piping so the plant could connect the next day, and it did, and we did that. So that was Polymetrics. We did that, and then we had a big job in Malta.
Malta plant, right.
5.3 MGD seawater plant in Malta, and then with it there was another plant in Malta that we did at the same time in highly brackish water, and that had a 5-year O&M contract extended for 7, so it's 12 years of O&M. I wasn't with Poly that entire time. Polymetrics eventually went under because of the economy, and that's why it ended up in CH2M Hill.
Yeah, I remember the Garlapsi plant because I was at Hydronautics then, and we competed for that project. we of course did not have the benefit of actually having a seawater membrane, as you guys did with the B10, which I think was also in Yambu.
Yes,
The
yeah,
B10,
we used the B10 there.
DuPont B10.
Yeah. Polymetrics was a DuPont licensee, but we also did other systems using other membranes. We used spiral membranes there as well.
Right. Then, and I'll come back to that in a minute because there's a couple other things I want to ask you about polymetrics. But Jim, you went to the Navy, and you worked on some of the early Navy work and the development of ROPU and some of the other military systems.
When I got there, the Army had already developed the ROPU at Fort Belvoir. Many had been purchased. Some had actually been put in the Falkland Islands, and we started hearing some stories about how things were not working well. Particularly the multimedia filter internals fell apart and all the sand went into the membranes. And so we actually started a program to look at improving the ROPU. So we had a ROPU delivered. When I came there, I was working with Ted Kepper, who was kind of in charge of the program, and we built the test facility, which is still there. It's just at a different location, back starting in '83. So we had a ROPU there, and the first time I did an SDI, the filter pad came out dark orange, and they said, there's a little issue here. So come to find out, the system had been built with, Culligan had provided the filter. It was supposed to be all stainless steel internals. They were coated steel, and they didn't hold up in seawater. But the real issue is that when the spec was written by the Army, they asked that the unit be tested with synthetic seawater, and they never flushed the units afterwards. So they buttoned them all up, put them in storage, whatever, sent them out, and of course they corroded.
Full of salt water.
So Culligan, because they had put the wrong internals in, they had to, under contract, replace all the internals inside the system. I'm talking about units in storage and in Fort Irwin and other places. It was a rather expensive proposition for them to do. They weren't very happy when they showed up, and I said, we got a problem here, guys. So it was an interesting exercise to work within the government system. But we went on to develop a 1,600 gallon per hour ROPU. We did some field testing out of 29 Palms. In the process of that, we looked at a lot of energy recovery devices, including when the Oaklis brothers first developed their concept of the hydraulic turbocharger. They came to Port Winnie and said, can we test our prototypes there? So we worked with them, and they did a lot of testing. They developed a lot of the materials and ceramic seals and so forth. So really that was kind of the test bed, gave them the opportunity to really develop that product, which is now, of course, quite successful in the industry. So we felt like, even though we were working for the government, sometimes you don't think like you're having any impact upon the civilian world. That, in fact, was a good example of kind of an opportunity to help take a commercial product to market.
Right. Now, in those days, we were still learning about materials for seawater plants. Which,
the ROPUs,
Yes.
the ROPUs were 316,
yeah.
and of course they used 6-inch pressure vessels, which are the same ones that had a Jetta. They were the studded. And I kept looking at these studded vessels and saying, I can just picture the guys out in the field looking at, this relatively large nut where it says put only like a few foot-pounds of torque on it, just cranking down on this thing and just pulling the stud right out. And, I mean, there was many things about the ROPU. They use shimp. If you ever try to bat shimp up in cold seawater, it doesn't do quite well. They use cationic polymer as the coagulant. Well, of course, a little bit is good, a lot's better. I mean, there was just a whole slew of things that could go wrong. But, and this is maybe appreciate the military, you're trying to put together an RO system, drop it from a plane, have it work out in the field with limited logistics, and say it's really not, the RO system isn't the issue, it's the context of what you're trying to do that's really the challenge. And you have to make compromises to do it.
At Yambu, and at that time, all the seawater plants really used 316L stainless steel.
Right.
And it was pretty well known that, especially at welds and under the Victaulics, that you'd get pinhole leaks, and eventually. And when we did Malta, which was the largest seawater plant in the world at that time, we didn't want to just put 316 stainless steel in again. We wanted to try some other things. We ended up having to do that on the manifolds on the skids, but a lot of the large piping we used polyethylene lined carbon steel, and then and that worked for a while. I was there a year or so after it started up, and someone showed me a piece of the lining that had basically unwrapped in the pipe, came loose, unwrapped, and it got caught right before the one of the transfer pumps. So it was the early days. They didn't have the new materials that you have nowadays.
That's right.
But
Well, that was
it was recognized in an issue, but everyone was trying
Yeah.
to figure out a way around it because we
Yeah.
didn't have the super duplex and the AL6XN and things like that we
That's
use
right.
now.
That's right. Well, that was in those days also. The thermal guys were having the exact same problem. I mean, I can remember, the famous OSW Universal Desalter, which was constructed of carbon steel, and the object was to make it for $1 a gallon, right? So they made it of carbon steel. Well, they achieved their goal, but it didn't last but about 6 months. So after, I'll get back to polymetrics, because polymetrics was kind of I won't say elementary school, but a prep school for a lot of people who are now in the industry or have been through the industry and now retired. So Dave Grunow was there,
Yes.
Mike Nelson was there,
Yes,
Dean Bedford was there,
yes.
Chris was there,
Chris Miller.
Chris
yes.
Miller, and you were there.
Bill Andrews.
Bill Andrews was there. And what's happened to those people, do you know? Well, we know what happened
Well,
to Dean. But.
Well, Bill Andrews, he lives in Bermuda, and while he was at Polymetrics, he was developing the pressure exchanger energy recovery. It was kind of at its infancy, but when he ended up leaving, when the custom RO design division of Polymetrics closed down, he ended up going and developing that product further into the DeWeer product that you see today, and then he was using that in some of his projects that he was with the companies he was involved at that time, and then eventually it was sold to Calder. So I think he's still, I don't know, I think he's still working on the side, but he's semi-retired.
Yeah, he's doing that. I actually ran into him in the airport in Miami one time. He was on his way back to Bermuda, having just purchased a yacht. So I thought, how nice. Here I am, Andrew. I'm still running around trying to make a buck, and he's running around buying yachts.
And Dean Bedford, he was in Yuma. He was in Polymetrics when I was there, and then he was also in CH2M Hill in Gainesville, Florida, when Jim was there as well. And he wanted to get back to the OEM. He wanted to touch the equipment and build it, and instead of just doing engineering like we do. And so he got back into the. He lived in the Caribbean in Tortola in the British Virgin Islands, and he operated facilities at that time, and through a number of different companies. It started out with
Aqua Design.
Aqua Design.
Aqua Design.
Yeah, he was there.
He worked, I think, a little bit for DVT. They were bought by Ionics at that time, and then a little bit after that, he worked for DuPont for a short amount of time, and then and that's where he is right now. He's working for TSG. They're an OEM, and they're also in Gainesville, Florida. So he's been doing that for a while now.
Yeah, the fallout from Polymetrics became Aqua Design, pretty much, didn't it? Because Dave
Yes.
Grunow started Aqua Design.
Yes. When Polymetrics still exists, by the way.
Still exists, right.
They do ion exchange regeneration in Silicon Valley, and do a lot of that kind of work. And a lot of the small custom units that we made, the package units, I think I don't know if they still sell them, but at that time, it was the large system design and build and operation is what was closed down. At any rate, a lot of the people started Aqua Design. Mike Nelson, Chris Miller. I went over there for a little bit as a consultant because I was looking to do something different at that point. But yeah, and then and Dean Bedford. was there too.
Yeah, yeah, good.
I think Dave Grinnell, I know he spends part of the year in New Zealand
In New
because
Zealand,
I had,
yeah.
when I was with CH, we did one of the first major capacity-wise MFUF systems we did for a city called Tauranga down there south of Auckland, and I got a call from Dave and he wanted to interview me for the WDR. And he says, "Oh, I'm up here in the Bay Islands, wherever, and I bought a place up here." So I said, "Oh, kind of nice, Dave. It's
Yeah.
a nice place down here."
Yeah, yeah. I remember we went. I forget when it was, but I met him for lunch up in Healdsburg one day, and he told me that he was going to spend part of the year in New Zealand. This was many, many years ago.
I was down there in '96 and '97, and at that time, the exchange rate was 55 cents on the U.S. dollar, and things were relatively inexpensive. So I suppose he probably got a pretty good deal on buying a
I
property.
think Chris Miller, went to Trinidad. Don't know if he's still down there.
Well, Mike
And
Nelson went to Trinidad as well, didn't he?
Yeah,
Went to
but I think
South
Mike still lives in California.
Mhm.
But I think Chris actually went down there and moved down there for a while. Yeah.
Yeah. So you both wound up at C.H. Hill, and eventually you moved back to Arizona. How long were you in Gainesville?
I was in Gainesville for 5 years, from '89 to '94, and then as much as I like Gainesville, I just decided, for a couple of reasons. One, I think it was good for us to have membrane people or desalting people in different parts of the company, so we could help, geographically service the company more effectively. And I kind of missed the West. Like Arizona got into my blood, so I kind of missed the mountains and the wide open spaces. And
The dust storms.
well, those weren't around until recently. But
And we were getting a lot of pressure because I was there, Jim was there, Dean Bedford was there,
Yeah.
Chris Burris was there.
That's right.
So
That's
having all of us in one location, the company kind of liked it. We could spread out a little bit.
Yeah, well, you probably had the same pressures I had at Boyle. It's billable time is important.
well, I think the other thing
And
too.
in those days, there weren't that many projects going on in Florida.
And I think being in Gainesville is, we're a large design center, and design centers it's all importing work, and I
Right.
wanted to have an opportunity to get out and spend kind of time, where clients
Yeah.
were. So
Yeah.
it gave me an opportunity to do that as
Yeah.
well, and be closer to California, which is always nice to visit.
Yeah. Well, in Gainesville, you started, one of the earliest projects in Florida, which was engineered by one of the predecessor companies of C.H. Well, not predecessor, but one of the companies that C.H. Hill purchased, which is Blackcurrant Eisness,
Yes,
is Cape Coral.
yes.
And did you get to work on that at all?
No,
No?
Cape Coral was before my time, and when I started, Inglewood Water District was
Right.
just built and had been running for about a year, and there were some interesting things that were happening in operations there that I got involved in at
I
Inglewood.
remember.
So that was the first time.
Yeah, because I was working for Hydronautics then.
Yeah.
So,
Well, the Inglewood plant was interesting in that the groundwater it's a brackish groundwater. It was very clear, low organics, but somehow it was causing a lot of flux decline on the membranes. And the feed pressures were rising up fast. In probably over a year or so, we were at the maximum pump capacity. And that's about the day that I got hired to come in. So I worked on that for a year or so, a couple of years actually. And we did some interesting test programs that you might remember at that time. We had for the plant expansion, they didn't want to just do the plant expansion without trying to figure out how to get around this fouling issue. And so we did what we called a membrane characterization program, and all the membrane manufacturers at that time, the major ones, they all pilot tested at Inglewood on this clear groundwater, had low SDI, low turbidity, but it was brackish. And I noticed that, and they tested they're all in parallel, and the flux decline that they had was all essentially proportionate to their flux rate. And I remember when testing was done, the manufacturers got their elements and they autopsied, cut them open. They're saying, "Man, these membranes look brand new, but we had all this flux decline. We can't figure out what's going on." It's interesting because the Inglewood is a utility. They're just looking for a way to solve the problem. They don't have money to do research, and so what they did is we did is worked out design criteria for each membrane type for bidding for the expansion, and based on the flux decline that they had during the pilot testing. So basically, operating at lower flux solved their flux decline problem. But we thought it might be some type of organic fouling, but they have low organics. So it never was money to research it. But from Inglewood testing, which was about 1986, maybe this test was going on, maybe 1985. The manufacturers all started their criteria saying for groundwater, you could have a maximum flux of this in their guidelines. All the manufacturers started to develop their guidelines on flux depending on water quality coming in, source water. And I think that Inglewood had a lot to do with that because that was an eye-opener for a lot of companies.
I actually still have a copy of your report and a photograph of the plant. Everything's painted dark blue.
Yes.
Looked like something that Darth Vader would have invented.
Well, that was another interesting thing about Inglewood is that separate from this thing, they had a microbial fouling problem because at that time, a lot of the pressure vessels weren't, they allowed light to go through. They're transparent. And so, it turned out that Paul Laverty, working for Hydronautics at that time, and we set up a test program that's kind of complicated to describe here now, but we looked at looking at opaque and translucent tubing. We used SDI pads for the measurement of fouling. We used different types of scale inhibitors, and came out that the water has no oxygen in it. It's got hydrogen sulfide, like a lot of Florida groundwaters has. But anyway, it was a sulfate reducing bacteria that was doing it, and so they ended up painting everything. There were the light coming in from the windows. Actually, the lights in the building had the fluorescent lights put out a wavelength that was great for growth of these bacteria. And so, now all the pressure vessels are opaque.
Well,
at that time it was painted. That's why they're all blue.
But the original plant was the old Hydronautics clamshell
Yep,
vessels.
clamshells.
And that was the first plant they built, I think, where they didn't have the color in the resin. Because up until that point, they had all been blue.
Yeah, that one was...
Because the ones we had at Sanibel, which was a couple of years earlier, were all blue. Yuma was blue. Yeah.
So I don't know why they did it the way
they did it. They were trying to save
money. But again, I came in after it was already there, saying, "Here we go."
Yeah, that's right.
And
that's right.
Inglewood's also an interesting. Another thing interesting about Inglewood, it was the first plant that had interstage boost pumping and energy recovery in a brackish system.
Right.
Well, actually, any system, as far as I know. It had a integrated turbo pump, vertical turbine can type pump with the energy recovery on it, and then it also had an interstage boost pump for flux balancing.
Right. The Englewood story is an interesting one because it went on for some time. And as you say, they didn't have money for research. They're like all municipalities. They're interested in, their goal is to produce water 24/7 on a routine basis, and so that their customers turn on the faucet, there's water there. Because I remember when I worked at Sanibel, the last thing we wanted was to have somebody call up on the telephone and say, "I don't have any water." That means you're not doing your job as a municipality or a water supply company. When you left Gainesville, Jim, you came back to Arizona?
That's correct.
And you started looking at your resume, you started working on things other than RO that had to do with membranes, like membrane filtration?
Yes, that's correct. The membrane filtration business, of course, the first plant that went in the U.S., I think, with MEMCOR of any size was, of course, in Saratoga, California, in '93. And before I came there, of course, we had done the first, I'll call it the pioneering project with the use of microfiltration ahead of RO for treatment of secondary or tertiary effluent. That was, even though that project never went, Reedy Creek, at Walt Disney World, for those who don't know Reedy Creek.
In Florida.
Right. So I would drive down to Walt Disney World and work in the sludge dewatering building where we were doing the pilot testing, and then well, at least the bench testing. But at that point, that was my first introduction to, we'll call it continuous flow microfiltration, which existed in different industries. But of course, Bob kind of kicked off the program, he and Dean. So we were all involved in Reedy Creek at the time. I just happened to be the guy that was kind of on site doing the work as the junior process guy. But
You're also doing some ceramic at that time, too.
right. So because MEMCOR turned out to be one of the leaders in the field at the time, though, we were evaluating different products. So we actually had, at a bench testing level, we actually had a little hydronautics tubular system there, and I worked with Maggie Wolf when she was with Hydronics, Nito Denko's product. So we were looking at UF at the time. And then when it came time to do pilot testing, we actually brought in not only MEMCOR, but we had a ceramic system, Alcoa separation zone that at the time later sold to US Filter. People were out of Rockford. And that was interesting because they put a lot of work into it, and they were trying to get 1,000 GFD flux, which I'm going, wow, if you can do that, you're pretty good. All based upon the economics of what it costs to manufacture the module. Right. So they worked very hard, but at the end of the day, they said the water's too clean because they had kept adding 50 parts of ferric to precondition the membrane. It was kind of like a DE filter in a way. So it was an interesting exercise to go through. We actually had, at the end of the program, we had Dow bring in a Norrit UF product that they had been teamed with. They had partnered with Norrit at the time. Not the Aquaman, or not the one that they had over in the UK in the early days.
Tested at Heemscook? For Heemscook?
Yeah, I think it was essentially the Ziga product at the time, and they didn't call it that. And it was not, I think it was arranged differently before Pure Comp kind of redesigned the system. So that was my first exposure to MFUF, and of course, although Reedy Creek didn't go forward as a project, we gave a lot of presentations, and at the time, after a while, I felt like, God, I'm doing a lot of free marketing for MEMCOR, because I'd be up there and there'd be all the MEMCOR people sitting in the front smiling, going, "You're doing a great job, Jim." It's kind of dumb, but anyway, I was young at the time.
Well, you did some. I remember reading a paper you wrote on Reedy Creek where you had done some work with ultraviolet.
Right. So when we set up the pilot testing system, we had the MEMCOR system there, and that fed the RO, but we concerned about biological fouling on the system. And of course, Water Factory 20 would have been in operation for many years, and we knew that they had chlorine present in the CM membrane. So we didn't really feel comfortable feeding any kind of a chlorine product to the membranes. And at that time, this was back, I think, at the tail end of the whole litigation between the Film Tech and the other suppliers. Remember the days, and we were doing testing at Cooper City, I think, not Cooper City, but Fort Pierce. We had to use the off-brand membranes at the time and go through and qualify because we couldn't use the fully polyhermetic. So we actually had I think the Tricept kind of DuPont cyclic aromatic product there, and we were concerned about an exposure to anything, chloramines, whatever. So we had UV in an attempt to try to control the biofouling. It was interesting, yes, the UV did knock down the bacteria by about 2 logs, but 30 feet down the pipeline, the bacteria were back up. But we didn't have a biological fouling problem, and I think I attributed this as pure speculation on my part to the fact that we were taking the phosphorus level down so low because we had to meet a phosphorus goal of less than 0.04, and we essentially were able to do that with the MF with coagulation. At the end of the day, we didn't even need RO for the project. But I think because we took the phosphorus so low is that we actually inhibited the bacteria from growing because we were starving them for an inorganic nutrient.
Food away.
Which would be interesting to explore that, and I'm sure people like the Dutch would look at that because they don't like to use any chemicals. But so the UV was there. it showed me that yes, you can knock it down, but it's not going to be a technology that's really going to control biofouling because there's no residual.
Right.
The other interesting thing is that with the UV, we actually scaled the UV light lamps up pretty quickly with iron. And the little bit of iron that actually got through the MF that was kind of dissolved, scaled. So we actually moved the scale inhibitor up front of the UV, and it took care of the problem. So it was, you know, the little things you find out during the testing.
That's what's grown the industry.
Yeah.
Little things like that.
So you're right, MF. When I went to the Phoenix and there was more MF, I said, you know, this is a technology that I want to be involved in. It was interesting. I said, well, this is easy. You know, you got particles. There's not going to be no chemical scaling. Well, of course, we all know better than that. So get your eyes open pretty quickly once you.
Yeah. Well, I ran into you on the Twin Oaks Valley project, which C.H. Sherm-Hill was successful in obtaining. And I regarded that as an interesting exercise for me because the proposals we received were so entirely different. I had assumed, in my ignorance, that all of the proposers would propose membranes. And that was not the case, which really surprised me. But you guys did, and you proposed xenon. And could you, without giving anything away, could you perhaps tell us how you arrived at the xenon approach rather than another manufacturer?
Well, of course, at that time, I think most people were of the opinion that submerged membranes for large capacity plants were the least expensive way to go versus pressurized. There hadn't been that many big pressurized plants built. And so by going to a submerged plant, you can reduce down the ancillary equipment. So you could make bigger trains, essentially reduce the number of pumps. We had already gone through and essentially designed the Lakeview plant in Ontario, which was almost 100 MGD, was 95 MGD. So we had experience with that, with a plant of similar capacity. And then, so we said, well, we're going to use membranes, 100 MGD plant. Really, there's two submerged suppliers out there in the business. It's GE or Xenon at the time before GE bought them, and US Filter with Memcor. So we actually got into parallel discussions during the proposal phase with both suppliers, and you know it was, I won't say touch and go, but it was close. At the end of the day, we just decided to go with Xenon. On basically, it came down to cost and what kind of service agreements we could put in place, because essentially we had the contract to operate the plant, but we knew that the membranes were really the key part of making the plant work, so we had to put in place a very good service agreement that would allow us to make sure that we had Xenon on the hook to make sure the membranes were going to work. So
that was actually, I was with Boyle when we were working on the original plant for Livenhain Municipal Water District. And that was one of the key factors in the selection of xenon for that plant, was not so much the pricing, but it was a long-term service agreement that they were prepared to enter into, and the others weren't. I'm not quite sure if Dr. Benedek was so confident in his membrane he could do that, or if he didn't know enough and he was just hoping.
No comment.
No comment. So
he was a very persuasive individual.
Yes, absolutely. He persuaded GE to pay him a lot of money to buy the company. So,
well, I think at that point they were having difficulty manufacturing the 1000 product, and I think their stock was suffering, and I think GE said. In fact, I have a conversation with somebody the other day who had met with Andrew, and he said. Emmett called him up and said, I want to meet with you for lunch. Made him the offer the next day.
It was a done deal.
It was a done deal. I can't really pass that up.
Yeah.
So.
Yeah. You've both seen a lot of progress in the technology, not only here in the U.S., but around the world, and you've all traveled extensively around the world. What do you see, I'll start with you, Jim. What do you see as the future of membrane technology? Now, and I can remember when UFMF was the big deal, and Scott Freeman's curves were asymptotic.
0 to 60.
Yeah. And now, you're sort of hearing the same thing about MBR. Everybody wants to have an MBR plant. Seawater RO appears to be well established, although there's still a lot to learn, I think, about that. Brackish water RO, I don't describe it even as interesting anymore. It's so routine. Particularly in Florida, it's except for Englewood, it's primarily routine. Surface, that's a different matter. But where do you think we're going in the next 10 or 20 years?
Well, I think you're right. I think the RO market is fairly well established. As you say, brackish, there's not really a lot to do, maybe tweaking around the edges in terms of energy recovery and kind of getting that refined to the point where it's maximized. I think seawater, the RO side of it, is almost there as well, although we know we have opportunities for products that can bring down the energy consumption of the membrane and still maintain the TDS rejection needed. And nano H2O being the example of somebody who's commercialized something that has the potential to bring the keys with the development of membranes. I think really the key is, will membranes remain reverse osmosis? Will membranes remain the technology of the future in terms of desalting? Will we have aquaporins or something else, which are membranes in a sense, but they're a kind of a step forward in a very different way. So I think we've basically reached kind of, and I hate to say this, we've gotten close to the end of the road with a typical polyambid membrane. We need a new product, and I think we'll see that. I think Eric Cook wrote a very nice review on nanomaterials and membranes, and there's some interesting things going on in the industry that I think may take a while to get to fruition, but I think given the number of things that are happening, I think something will happen that will continue to bring down the cost, so to speak, of the energy. But that's so on the high pressure side. I think obviously we have other ways of approaching the issue with forward osmosis and MD, and I think membrane distillation to me is very interesting because it has the opportunity to deal with poor water quality and higher salinity water quality, where we can get away from the osmotic pressure limitations of RO, but we have to have something obviously that can achieve sufficient recoveries to make it worthwhile, so we don't have a lot of MD membrane capacity, just like you would on a distillation plant. So I think that the MD has an opportunity, particularly if we can capture and combine it with something like solar desal. I mean solar energy. I think that combination from a sustainability standpoint, I'm kind of excited about that. I think it's going to take a while, but I think there's opportunity, and certainly the Spanish are doing those things.
You don't need a very large pressure temperature differential.
Right.
So it would lend itself to solar energy, I would think.
Yeah, I mean we can go with a Fresnel collector-based system. We don't need this concentrated solar power necessarily to drive it. So I think to me the thing that's constraining the membrane industry and the brackish side is the concentrate disposal issue, and I think we've been struggling with this for many years. But it's kind of the tail that wags the dog in terms of being able to tap into inland brackish desalting opportunities right here in the valley, for instance. So it's not a desalting issue, but it is in a way, and we have to really apply some ingenuity to come up with that. So I think there's some crossover between MD and some of these other things. We can apply it not just to desalting the water for drinking, but actually dealing with the concentrate in a more sustainable
so you'd have
manner.
one technology for the water treatment and another technology for concentrate management.
Right.
Yeah.
So we need an integrated approach that really gets us to ZLD or close to it. We can't afford what they do in the the SAGD industry or something. We don't have that energy available at no cost. So we need some new technologies.
Right. Bob, what do you see in the future?
Well, I think Jim said it pretty well, but I think that sustainability is it's kind of a word, but it's really there. I mean, so many plants really aren't sustainable from a cost standpoint or from an environmental standpoint. So sustainability, using renewable energy, concentrate disposal. There's more and more talk, and there's more and more plants looking at ZLD, zero liquid discharge, but they're extremely expensive. So maybe using other technologies that evaporative technologies, A lot of those plants use concentrate minimization with chemical clarification, but there's a lot of technologies that are out there and a lot that are popping up over the last few years to help that situation. But I think that more environmental, sustainable is going to be is where the future needs to be, really. And on the other side, I think that there's so many people in the world that don't have access to good, clean, fresh water. And if you look at the amount of people in the world that don't have access to fresh, potable water, finding technologies that are inexpensive that you can put out and will have a big impact in the world. And I think that membranes are a big part of it, using solar or other types of energy. But I think that we have a tendency to think of big plants and municipal plants and industrial plants, but with so many people in the world, billions actually, that are without fresh, clean, potable water, there needs to be an effort there as well.
Right.
And I think that's part of the future too.
My final question for you, Bob, is during your time in the membrane industry, have you ever thought, let me rephrase this, I'll ask it in two parts. If you had to name one person that influenced your decision to stay in the membrane technology business during your career in the consulting field, who would that be?
Probably the one person that influenced me the most was Jim Slay. Jim Slay was an old fluid systems person back in the old Roga days, and he was at Yuma when I got my start in membranes and desalting. He moved to Polymetrics, and that's how I got up to Polymetrics. He hired me up there, and I'm still friends with him today. So Jim Slay is, I think, probably the most influence on me in my career.
Yeah. Well, having said that, do you ever have a feeling of regret that you didn't concentrate on solid waste management or some other field of engineering?
Actually, no. There's other fields that you can make more money. You can go into business and finance and banking and all those things. But I'm an engineer at heart. That's me. And I like working on projects from the front end of a project through the design and construction and operation. I worked for a water utility for a number of years, manufacturer and OEM that did operations as well, and at Yuma. So I just find the whole industry extremely challenging and interesting, very interesting, and I wouldn't do anything different, really.
Yeah, good. Jim, how about you? Who would you say was the one person?
Yeah, I don't know. I was thinking about that while Bob was answering. I don't know if there's any one person. I think really what got me energized was going to Yuma and being in an environment where we had, first of all, a lot of people that were coming there and being exposed to reverse osmosis and pretreatment together. We had a very strong bond, really, because you're in Yuma, there's not a lot to do, so you spend a lot of time together working. And I think the environment at Yuma, where it's hard to believe now, but the government spent a lot of money. I mean, we used to analyze everything. We used to plot salt passage for every individual line. I mean, you really got immersed into not only the practical side of it, but the research side of it through all the work that we would do trying to understand these fouling issues and other things that when we looked at a project that just looked at different filter papers for the SDI. I mean, you don't get that kind of opportunity really any place else where you can do research and you can do your PhD thesis, but actually applying it to a real project. So it was really the Yuma project that got me excited about membranes and reverse osmosis, which was at the time that electrodialysis. That's what it was. But I think it wasn't just one person. I mean, certainly working with Paul Laverty was interesting. I mean, as Bob said, a very smart guy, was an operator, and really brilliant, taught himself just about everything he knows about the industry. So just working with people like that just gave you kind of you wanted to get up in the morning and go to work just to kind of be in that environment. So.
Yeah, you talk about Paul Laverty being an operator. When I was at Yuma Desalting Test Facility, he was one of the lead operators. And I was in engineering, and I'm looking at this guy and saying, he is so smart and he knows so much. We got to get him into engineering to help write these reports and work on these studies. And then, so that's what we did. And then when I left, he became
he was the senior consulting engineer, so I worked at.
Then he went to Hydronautics and.
Yeah, and is still there as the vice president of engineering. So he's
Well, he's with H2O Innovations.
Yeah. Membrane Systems and H2O.
Yeah.
Yeah. He's. So there's probably not one seminal person. Certainly, Dennis Casper was a mentor when I worked with him. Went on to. Because he'd been in the business a long time and really he could give me a good perspective on the consulting business as well, which is what I went into, obviously, when I took the job with him. But in response to your second question, no, I think, I actually started first semester in engineering as an undergraduate and said, this is kind of boring and people are kind of boring and they all look like geeks. And so I changed majors and came back to engineering later in life. But what was exciting about environmental engineering is that you're exposed to a lot of different things, whether it's biology, chemistry, the engineering part of it, and different people in the industry. So it's an opportunity to really stay involved in a lot of things. And I think with CH, what's been exciting, because I consider myself to be kind of an ADHD person, focusing on one thing for too long is rather challenging. So working for a big consulting firm gives you an opportunity to be involved in a lot of projects, which really, really gets me up in the morning.
Good. Well, we've all been around since the beginning, pretty much. Not quite the beginning, but close there too. And how much longer are you going to do it, Bob?
I'm going to fade off in the distance, though, one of these days. Actually, my wife had some health problems at the end of last year, and so I decided to go part-time. I'm working only 40 hours a week now, 39, 40.
It's part-time for consulting.
None of this 50, 60 hours anymore. So I'm part-time, but working nearly full-time. And I think I see myself kind of slowing down to maybe 30 hours, 25 hours for maybe a year. Who knows? I'll have to see how it goes.
Yeah.
But I don't have to, I'm not traveling as much as I used to. I want to stay home more.
Yeah. How about you, Jim?
I guess I don't see myself changing status from full-time to part-time. Certainly not retiring. I don't think people do that anymore these days, but unless they happen to be Dave Grinnell or somebody can afford to do that. But I think that I'll probably work at least another 5 or 6 years, unless something happens, either obviously to my health or whatever. But the business we've weathered the storm pretty well, Eastham Hill, so it's been slow, but I think things are picking back up, so there's certainly a lot of opportunities. I've transitioned to a different role. I used to be the global technology leader of membranes with Bob, and now I'm the global technology leader for desalination. So we could maybe consider that the same, but in terms of CH, it's a little bit different. And so I've got look at the market in the Middle East, for instance, and other places. And so it's...
Dave Gruner used to have an expression that he's mentioned to me more than once. He said, and we're talking about how do we get into the industry, and he said, well, because it looked like it was exciting, we found out it wasn't, but then we didn't know anything else, so we had to stay here. And he said, we'll never die. He said, we'll just become Dame Bramaged. So with that, I'd like to thank you both for being here. It's been a real pleasure, and I wish you many more years of success.
Appreciate the opportunity, Ian.
Bob?
Thank you, Ian. Thank you.
Thank you. And that's all. Keep tuned until our next session, which will be upcoming sometime this year with my good friend Doug Eisberg, who you can't see, but he's sitting there keeping an eye on me. He and I will be getting together to put together another one of these Pioneer Chat sessions in the near future. So thank you.